Okay, here we go. So here's the first current worksheet and going through the answers. Units for potential difference. Potential difference is the same thing as voltage. So it's volts. Okay, what's commonly called electric potential difference? Voltage, like I just said. Okay, the flow of electric charge. So flow, you should think current, like water current. All right, and we measure current in amps or amperes. All right, complete statements. Everything with this, with charge and coulombs per second, is going to be a 1-to-1 ratio. So 1 amp is 1 coulomb per second. So 15 coulombs every second is going to be 15 amps. Make sense? Okay. 1 volt of potential difference between 2 points is 1 joule. Again, everything's going to be 1-to-1 ratio. So it'll move 1 coulomb of charge. Which offers more resistance? All right. Wide or narrow? Well, it's going to be narrow. Okay. Wide or thin wire? Same thing. A thin wire is going to give more resistance, which is why if you're going to run a wire to a speaker, it's a really small speaker, you can use a thin wire. But if you have a lot of current going through there, it's going to be a lot harder, and you need to have a you're going to need a thicker wire if you're going to have a lot of current going through there. All right, next up. So how much current flows through a 1,000 ohm resistor when you have a voltage of 1.5 volts? All right, so it's going to be this thing here. And you can just think, whatever you're looking for, you can do this. I mean, V equals IR is pretty easy algebra too. V equals IR, right? So if whatever you're looking for, you can divide out or multiply. If you want to do this little cheating thing here, you can. If I'm looking for current, I put my thumb over current, okay? So I put my thumb over current, and that means voltage divided by resistance gets me current. Okay, so we're just going to do 1.5 divided by 1,000, and that will get your answer of 0.001 amps. Okay, next thing. I'm giving you 3 ohms, so I'm giving you resistance, and I'm giving you a 12-volt battery. So again, you can use this formula here. Voltage is 12, resistance is 3, and I need current, and you get 4 amps. All right, how much resistance for this one? So I have 10 ohms, okay, and I have 12 volts. So I'm going to have 12 volts divided by 10 ohms, or you're going to have 1.2 amps is your current. All right, what is the current of 30 ohm heating coil and 120 volts? Again, so we have 120 volts divided by 30, just doing Ohm's law, V divided by R, and we get 4 amps going through there. Okay. Voltage 6 volts, 2 fingers. Okay, so we have from 400,000 volts, 400,000 ohms to 200,000 ohms. What's the initial current through the fingers, and then when it drops? So again, we're just going to do Ohm's law. 6 volts first divided by 400,000, and then 6 volts divided by 200,000. And we will get that, plug that in a calculator, and get 0.000015 amps, and that number, 0.00003 amps. Easy enough? Good. Next, you have 6 divided by 0.006, and you will get 1,000. Okay? You have 120 volts divided by 12 amps, so 120 divided by 12, you get 10 ohms. Okay, you have voltage, you're looking for voltage, you have resistance, and you have 1 amp. V equals I times R, so this is going to be I times R, and you get 100 volts as your voltage going across. Okay, and now our last problem. It's asking if the resistance changes, because I have a set current with a certain amount of volts, and I have a different current when it goes through a different voltage source. So we can do our 120 divided by 0.5, okay, and we get one resistance that's going to be 120 divided by 0.5 or 240. So you get 240 ohms when you plug it up to 120 volts. What about when you plug it to only a 10 volt source? So you have 10 divided by 0.2, and 10 divided by 0.2 is 50. So does the resistance change? It does. There you go, and that's it. Okay. You are welcome. Hope that helps.